For the given question under discussion, we worked out the equations for streamlines, we worked out the equations for path lines, and now we want to work out the equations for streak lines. For the same question now, the values of u and v remain the same, and therefore these equations, and we write them in this form, that is, separate the variables as we have been doing, and then we integrate them from some arbitrary constant zeta to t when it comes to time t, and for value x and y from 1 to x and 2 to y. Integrating them, calculating the values, since the integration is very simple, therefore we don't have to explain it too much. We will obtain, for the time t, we will obtain what is given on the left hand side, and what is given on the right hand side involves x. This is from the first function, this one. And from the next equation, for the y component, we obtain this equation. And trying to obtain the values of t from the first function and from the first equation and the second equation, we have obtained these results. So, from these equations, we write them, we calculate as t plus half t square is equal to log of x plus some arbitrary constant c1, and similarly 2t plus t square by 2. Here we write some constant c2, so that they are different, because here the variable is x, here the variable is y. So when t changes, the x and y may not necessarily be at the same point, therefore the arbitrary constants are different. And then we take the boundary conditions such that zeta is less than t, and we have x is equal to 1, y is equal to 2, z is equal to 0, which are already given to us. We calculate these values and we obtain the constants c1 and c2 as shown. Substituting these values, constant c1 and c2 that we just calculated in our equations, we obtain these values, and now you can see that the constant c1 is eliminated by this value and c2 is eliminated and substituted by this value. These are two different values. But now we have an equation that involves time t, x, zeta, and of course in this equation instead of x there is y. So we can try from these two, we can again try to find an equation which maybe eliminate one of these variables. And from this we get t is equal to log of y over 2 minus log of x plus zeta. Or zeta can be written as, if we take all the terms to the left hand side, as t minus, this term will become minus, this will become plus, and therefore I write them as this, and we obtain another equation in which we have the combination of the two that gives us zeta is equal to t plus log of 2x over y. You know that we have a formula that log of a minus log of b is equal to log of a over b. So that has been used here. So since this is with the negative sign, we have y coming in the denominator and so on. And again, substituting the relevant variables, we now try to find out another form of this equation, which turns out to be this, and in this you can see there is no zeta. Now we have only time, x and y variables occurring in our equation. We further reduce when time is equal to 0, we reduce them to this value. And so another equation is formed, and here you can see that there is no time involved. So this term is gone.